Okay, let's take a look at some transformations of these exponential functions. Right, 3 to the power x reflected across the x-axis. So 3 to the x will become negative 3 to the x because it's reflected across the x-axis. If it's down 8 units, that's minus 8. And 1 to the left, so 1 to the left means plus 1 up here. And that would be the new function, okay? Now, the y-intercept of this is you setting x equal to 0, okay? So right here, this has to be 0. So it's saying, right, what's negative 3 to the power 1, and then take away 8. Well, negative 3 to the power 1 is just negative 3. If I take away 8, that'll be negative 11. Okay, so 0, negative 11. The domain, well, the domain of all these exponentials is actually negative infinity to positive infinity, no matter where you move them, okay? But the range of this, right, okay, if I flipped it upside down, so it's going to look something, okay, remember, here was the original, something like that. If I flipped it over the x-axis, it'll look like that. If I then move it down 8 units, okay, now what's going to happen is this. The horizontal asymptote, which is there, is now going to be down 8, okay? So, if that's what it looks like, because I move it down 8, doesn't matter about left or right, okay, with the domain or range. So, it looks like it's going to be negative infinity to positive 8, so to negative 8, okay? There we go, and it won't include it because it's an asymptote. Okay, so that should be the range, okay, looking at this, and this is negative 8, remember. Okay, let's take a look at some other questions. Write and sketch the transform function. Y-intercepts, horizontal asymptotes. Okay, let's take a look at this one. Now then, this here, this is this already, and I can tell that because it's negative in front, so it's over the x-axis reflection, okay? And look at this 5 here, okay? We'll look at that 5 there, right there, okay? In other words, if x equals 0, you will get negative 5. Okay, reflected over the x-axis, then all it's going to do is, I'll put a point up here, it'll look like this. Okay, there you go, as best I can. Okay, that's it, reflected over the x-axis. So that means this is going to be just 5, 0.5 to the x, okay? All I did is reflect it over the x-axis. Now then, how about this one? Again with this, look at this one here. It's over the x-axis, that's why it looks like this, reflection, okay? But again, look at this. If x is 0, then y is going to be at negative 3 right there, negative 3 y-intercept. Okay, we shifted up 3 units. Now remember, again, if this is the horizontal asymptote, then this is the new horizontal asymptote, okay, at y equals 3. Left 2 units, so just pick a point, Now we know this point here, okay, the y-intercept. In other words, if I go up 1, 2, 3, and left 2, I'm going to end up being there, okay? Now, really, the best way, that's it. You can pick some more points if you want to and move them up 3 and left 2, but it's going to be something like, well, actually, if I need to find the y-intercept, which I should have done, okay, maybe I should do that first. Okay, so if I do change this, okay, so I'm not going to put the y-intercept on just yet because I need to find out what it is. So my equation is going to be, it's still negative 3, because I haven't flipped it over the x-axis. Now then, if it's up 3 units, that's a plus 3 at the end, and left 2 units, that's x to the positive 2, okay? Because it's moved left 2 units. So, again, if x equals 0, I have negative 3, okay, to the power 2 plus 3 at the end. Now remember, this here, this is just a negative. I'm going to square the 3 first to get 9. This is negative 9 plus 3, which is going to give me negative 6. So again, I'm going to put a point here. And now I can do something like this. Okay, so that's what it will look like. So do remember your y-intercepts when x equals 0. It's not too hard to calculate. Okay, there we go. Let's try another slide here. Right, match the functions. Now, okay, so remember, if you take a look at this, this is the initial value. this is the initial value. This is the initial value. In other words, these are the y-intercepts, because when x equals 0, all of this part, the base and the exponent, will be 1. So actually, you can see there's a lot of these at y equals 2 right here, okay? A lot of those at y equals 2. There's also some at y equals 4. Can you see that right there, down here? Okay, so I think maybe I should tackle these first then. Now do remember, this is the one that has growth, this is the one that has decay. Again, this is decay because it's something less than 1, between 0 and 1. So this one, let's have a look, going through y-intercept of 4, must be C, this one here, that one right there. So this is C, okay? Therefore, this one, again going through 4, but with, which is this looks like it's D. Okay, that one is D. Okay, now then, some of the other ones. Let's have a think about this. So again, this one's decay because it's got something less than 1 as the base. This one's also decay. This one's growth, and this one's growth here. Now then, I'm going to do the growth ones first. This one and this one. And the reason is that I can see this one here has a bigger base, so it will grow at a faster rate. And that means, to me, that looks like E. Okay? Remember, E and F are the growth ones, A and B are the decay ones. So this looks like E to me, and therefore something with a slower growth will be this one here, okay? Because the base is smaller. Now, think about this now. If I do this, if I go 4 to the x and 2 to the x, well then this will have a faster growth. Now, if I do the reflection over the y-axis, so make it 4 to the negative x, or 1/4 to the positive x, make this 2 to the negative x, or 1/2 to the positive x, then can you see that this has a steeper growth, so this has the steeper decay, okay? So you've got to think now that although this number is larger for a steeper growth, this number is smaller than this one for the steeper decay. So I think B looks like a steeper decay, okay? So must have the smaller base, and that is that one here, okay? So this must be B, and this must be A, and that's it, okay? You can always check with Desmos with some of these.